Bismillahirrahmanirrahim. Still, we are speaking about the trigonometric function of acute angles, and this is the third part. In this part, we are going to speak about the trigonometric functions of special angles. And special angles, we mean the angles which is a 45 degree, 30, and 60. These are special angles, and we are going to find the trigonometric function of these three special angles. Let's start with the 45. For the first one, suppose that we have this triangle, which with side A, and square root of A. Or if we have 45, 90, and 45. This is triangle which has two equal sides, and this equal side we call them A and A. They are equal. Two sides have the same length. Suppose that these are A and A. If we have A, and using the Pythagorean theorem, we will find that the hypotenuse will be square root of 2 multiplied by A. Now, let's write the sixth trigonometric function for 45. Either I can use the lower one or the upper one. For example, if I use this one, then this is the adjacent, this is the opposite, they are the same, and this is the hypotenuse equals square root of 2 divided by A. So, number one, sine theta equal to, or let's say not theta, 45 this time, equal to. Now this is the opposite. This is the opposite. This is adjacent. And this is the hypotenuse. Now we know sine theta equal to the opposite divided by hypotenuse, which is equal to A in this triangle divided by hypotenuse is given by square root of 2 multiplied by A. If we cancel A with A, I will have 1 over square root of 2, and by rationalizing the denominator, it is square root of 2 divided by 2. So sine 45 equal to square root of 2 divided by the second one, cosine theta. Or cosine 45 is equal to the adjacent divided by hypotenuse. But the adjacent equal to A divided by square root of 2 divided by A. Also, I can simplify this. I will have 1 over square root of 2, or it is square root of 2 divided by 2. So we can notice now that cosine 45 and sine 45 are equal. So we have that cosine 45 equal to sine 45, which is equal to square root of 2 divided by 2. This should be noticed. Cosine 45 is equal to sine 45. Now the third trigonometric function is the tangent. Tangent 45 equal to the opposite, which is A, divided by the adjacent, which is equal to A. That will be 1. And this is also equal to cotangent of 45. So tangent 45 is equal to 1, and cotangent 45 is also equal to 1. So this is 3 and 4. Fifth one is secant theta, or secant of 45, which is equal to the hypotenuse divided by adjacent. This is equal to square root of 2 multiplied by A divided by A. This will cancel with this one. It is only square root of 2. And this is equal to cosecant. It is the same thing. It is hypotenuse divided by opposite. So this is equal to, again, square root of 2 multiplied by a divided by a, which is equal to square root of 2. So we can see that the secant and cosecant are equal. Tangent and cotangent are equal. Cosine and sine are equal. So if you have 45 degrees, then each two ratios are equal. Sine with cosine, tangent with tangent, secant and cosecant, they have the same values. This is for the 45. For the second special angle, which is that will be 30 or 60. For 30 or 60, see this triangle now. We will have let's see this triangle. If we have 30 and 60, think about this is 30, 60, and 90. The relation or the special relation between the sides of such a triangle is that the shortest side is equal to half of the hypotenuse. The shortest side is 1/2 of the hypotenuse. So if this is A, we can see the shortest is A divided by 2. And the height of the triangle is equal to the square root of 3 multiplied by A divided by 2. Now I have these three sides. So we can find the sixth trigonometric function. Let's start with theta equal to 30. So we are speaking about this one now. So if we think about 30, this side is the opposite now for 30. And this is the adjacent. So we can find number 1, sine 30 equal to the opposite divided by the hypotenuse, which that will be A divided by 2 divided by the hypotenuse, which is equal to A. This will give me 1/2. Sine 30 equal to 1/2. Number 2, cosine 30. It is the adjacent. That will be square root of 3 divided by 2A divided by the hypotenuse. Or I can write it down, dividing the hypotenuse. This will cancel A with A. So it is equal to square root of 3 divided by 2. So cosine 30 equal to square root of 3 divided by 2. Number 3, tangent. Tangent of 30 degrees. We know it is the opposite divided by the adjacent. It is A by 2 divided by square root of 3 A. This A will cancel with this one. So I will have 1/2 divided by square root of 3 divided by 2, or I can write it as 1/2 multiplied by the reciprocal, which is 2 over square root of 3. I can cancel 2 with 2. It is 1 over square root of 3. But it is recommended to not keep any radical in the denominator. So we rationalize this one to be square root of 3 divided by 3 by rationalizing. With the same thing, we can find the cotangent. Number 4, cotangent of 30. We just write it upside down. We know the cotangent is the opposite of the tangent. So it will be square root of 3 divided by 1. This is square root of 3. Number 5, secant theta. It is 1 over cosine. Let's say this is not theta, this is 30. From last time we said that the secant is the opposite, or I'm sorry, it is the reciprocal of the cosine. It is 1 over cosine, and we found cosine theta or 30 equal to square root of 3 divided by 2. If we take the reciprocal, it will be 2 over square root of 3. And again, by rationalizing, this is equal to 2 square root of 3 divided by 3. This is the secant theta. And the last one, number 6, cosecant, or cosecant of 30, which is 1 over sine 30. And sine 30 is 1/2. So if you take the reciprocal, it will be upside down, it is 2 over 1. So it is 10. It is 2. So cosecant of 30 is equal to 2. For the 60, if we think about 60 now, now this is 60. So this now, it is not the opposite. A over 2 will be the adjacent for 60. And this one is the opposite. So if you apply the same idea, we'll see for theta equal to 60. So we can post the triangle here, just to make it clear. Number 1, sine theta or sine 60. Now we are using this angle 60. Sine is the opposite divided by the hypotenuse. This is the opposite. So opposite divided by the hypotenuse will give me square root of 3 divided by 2. And actually, this is equal to cosine of 30. Sine 60 equal to cosine 30. Same thing for the cosine. Cosine of 60, which is equal to the adjacent divided by the hypotenuse, I will have 1/2. And this will be equal to sine of 30. Because these are complement angles. And we call this the cofunctions, actually. 30 and 60, they are complement angles from section 5.1 of the angles. We discussed the complement angles. Now we are using them to find the cofunctions, trigonometric and its cofunctions, the other function that equal to the same value. For the tangent, number 3, tangent of 60 is equal to, it is opposite divided by the adjacent. And this is equal to square root of 3, which is equal to cotangent of 30. Number 4, cotangent of 60 is 1 over square root of 3, or it is square root of 3 divided by 3, and this is equal to the tangent of 30. If you go back up to see it, this is tangent of 30 equal to the cotangent of 60. And the last two, number 5, secant of 60, which is equal to 1 over cosine of 60, that will be 2. And this is equal to the cosecant of 30. I can write it there also since we started. And number 6, cosecant of 60, which is equal to 1 over sine. That will be 2 over square root of 3, or it is 2 square root of 3 divided by 3 by rationalizing. And this is equal to the secant of 30. So these are the special angles, 45, 30, and 60. And these are the 6 trigonometric functions, how to find the values for these special angles. Let's have one example on how to use these special angles to find some exact value for some expressions. For example, sometimes we are going to find the sine multiplied by cosine or something different, maybe. Let's see this example. Let's find exact value for some expressions. So with that we have is a question. And we need to find the exact value for each expression. Question number 25, given that sine 45 plus cosine 45. And I need to find the exact solution. Start with the first one, 25. Sine 45 plus cosine 45. And we know that sine 45, from what we found up, is equal to square root of 2 divided by 2 plus cosine 45 will be square root of 2 divided by 2. And this will give me 2 square root of 2 divided by 2, or it is just simply equal to square root of 2. So this is the exact value of the sine 45 plus cosine 45. For question number 26, we need to find the exact value for cosecant of 45 minus secant of 45. Now cosecant of 45 is equal to square root of 2. And cosecant 45 is equal to square root of 2. We just go back just to see it in the 45. Up, we said that secant is 45 and cosecant is equal to 45. So if it is secant 45 minus cosecant 45 will give me 0 because these are equal. So the answer for this is equal to 0. So this is the exact value. Let's see question number 27. I need to find sine 30 multiplied by cosine 60 minus tangent 45. We know that sine 30 equal to 1/2 multiplied by cosine 60 is 1/2 minus tangent of 45 is equal to 1. So this is 1/2 multiplied by 1/2 equal to 1 over 4 minus 1, which is equal to minus 3 over 4. So the exact value for this expression equal to minus 3 over 4. Last one is 28. We have cosecant 60. So just write a question. We have cosecant 60 multiplied by secant of 30 plus cotangent of 45. Now cosecant of 60 is equal to 2 square root of 3 divided by 3 multiplied by secant 30 is again 2 square root of 3 divided by 3 plus cotangent of 45 is equal to 1. So this is equal to 2 times 2 is equal to 4 square root. With square root will cancel, so I will have only 3 divided by 3 multiplied by 3 will give me 9 plus 1. So this is equal to 12 over 9 plus 1, which is equal to 12 plus 9 over 9, or it is 21 over 9. Or simplify by 3, it is 7 over 3. So this is the exact value for the last expression, cosecant 60 multiplied by secant 30 plus cotangent of 45.